Hello. So in the last session we saw about how the TE field expressions are reducing to three field expressions which are Hz, Ey and Hx. So out of six field expressions we did not have Ex, Hy and Ez. So all these three terms became zero and the remaining terms are available. So two magnetic field and one electric field are available for TE10 mode. So these are the expressions, and we know for a guide wavelength this is 0, lambda g by 2 and this is lambda g. Fine. So here this is occurring at lambda g by 4 and this negative peak is occurring at 3 lambda g by 4. So the entire lambda g has 2 pi radians. So lambda g can be given by 2 pi divided by beta. So instead of beta, if I am substituting 2 pi by lambda g in these equations, I will be getting cos 2 pi by lambda g z sin 2 pi by lambda g z, and here too sin 2 pi by lambda g z. So we'll see the field expressions, field patterns now. You remember that Ey and Hx are similar, they have the sign terms. So whenever Ey or the intensity of Ey becomes maximum, then the intensity of Hx also becomes maximum. Now Ey and Hz, if you are comparing, this is in sine and this is in cos. So whenever Ey, these are opposite, whenever Ey is minimum, then Hz becomes maximum. Okay, so when Ey is maximum, Hx is also maximum. When Ey becomes minimum, now Hz becomes maximum. Okay, so this we have to remember for drawing the field pattern. So let us go to the field pattern now. This is your rectangular waveguide. Just imagine that this wave is propagating inside this waveguide, rectangular waveguide. This is x direction, this is y direction, and this is z. So this wave, when it is starting at 0, when I am considering the initial position to be 0, in the cross section I cannot see that wave because the intensity is 0. I cannot see. So what am I doing is I am assuming that this initial point as lambda g by 4. Okay, so I will extend this point and take the wave is starting from here. Okay, so that I can see the peak at this cross section. This peak value should be seen at the cross section. So I am considering that wave has started here itself. At 0 point it has started, and when it is reaching the maximum, it is lambda g by 4. Okay, so that I can see the maximum wave pattern here. Because I have to visualize the pattern, right? So I have to consider some assumption that the wave is starting here itself. So this is lambda g by 4. Consider that somewhere here lambda g by 2 is here, and 3 lambda g by 4 is here, and lambda g is here. So if the wave is starting here at 0 point, it will reach the maximum at lambda g by 4. It will reach 0 at lambda g by 2. It will reach negative maximum at 3 lambda g by 4, and again it will reach 0 at lambda g. So this wave is two-dimensional, right? You have to imagine the wave in three dimension. So just imagine this sine wave like a bowl, an inverted bowl, okay? So this inverted bowl is going to be the maximum peak of the sine wave. So when you take this inverted bowl, it is going to be in three dimension. So it is going to cover this entire cross section's length also, okay? So it will be like as if I've kept the bowl like this. And when it comes to negative maximum, the bowl is going to be upwards, okay? So the sine wave will be like this. One guide wavelength sine wave will be like this. So when I'm imagining it, the cross section is going to have the peak. Now this cross section is going to have this peak intensity, okay? So when I imagine this is positive peak, right? If it is a positive peak, the arrow mark should be in upward direction. And as it is, this is a sine wave, you don't imagine that only when it is going forward it is reducing. Even in the sideways it is reducing. Okay, so this is the sideways. In three dimension, if you imagine, this is the side, and when it is reaching the end, it becomes zero. Same way here. When it is reaching the end, it becomes zero. So you can see that only one half wavelength is available in the A dimension. This is A dimension, right? Only one half wavelength is available. Why? Because TE10 has only one half wavelength in A dimension and there is no half wavelength in B dimension. So I will not consider or represent any form of wave in B dimension at all. Only along A dimension it is available. So I have one half wavelength along A dimension, and I can see that I'm taking the peak value at lambda g by 4. Okay. Now you should also assume that whenever a wave is coming towards you, from top view if I'm seeing, the wave is coming towards me, right? So when the wave is coming towards us, the representation is a dot. And whenever the wave is going away from me, away from the viewer, then the representation is a cross. And why is it so means, for example, you just imagine a arrow. When the arrow is coming towards you, you can see the tip of this point, tip of the arrow, right? So how will it look like? It will be looking like a point, right? In the front view, if you're seeing, the arrow will be like a point. And when the arrow is leaving you, you can see the back side of the arrow and it will be looking something like a cross. So this is where the wave is coming towards, and this is when the wave is coming, going away. So here, from the top view, if I'm seeing, the intensity of this field is being maximum. So I have to put a point which is coming towards me as a big dot, and this intensity is reducing as it is going towards the ends, and here it becomes zero. Same way it is happening in the other end also. So now when I've seen the sides, right? So when the bowl is reducing at lambda g by 2. Now this is lambda g by 2. So at this point, once again the intensity is going to reduce, but it is still positive. Okay. So what is happening is, here it becomes 0. At this point, at lambda g by 2, it becomes 0. But the intensity is reducing. So it is still pointing upwards. You should represent it with dots. And it becomes 0 at lambda g by 2. Now, when it is reaching 3 lambda g by 4, the intensity is increasing but in opposite direction. So when you take 3 lambda g by 4, this intensity is going to increase but in opposite direction, which is away from me. From top view, if I am seeing, it is away from me, right? So I have to put cross marks and the intensity should slowly increase. And when it reaches 3 lambda g by 4, the intensity is maximum in opposite direction. Same way in the sides also. Just like this, in the sides also, it is having an invert, the bowl is like this, right? So the field will be reducing towards the ends. So at this point and at this point, it will become 0. So this is actually the EY, because the electric field is in Y direction. So all these are electric field, EY. So I have not drawn for the point from 0 to lambda g by 4, and I have not drawn from 3 lambda g by 4 to lambda g. Okay, the electric field representation I have not shown. I will say you the reason why. So now we will go for Hx and Hz. So I said that whenever EY is maximum, so here where EY is maximum, here it is maximum and here it is maximum, right? So when EY is maximum, which is maximum? Magnetic field in x direction is maximum. So x is this direction, right? So at this point I can consider that Hx is going to be maximum at this point. Exactly at this point. You just represent like this so that you'll understand. Okay, and here also the EY is maximum but in opposite direction. So I have to put Hx maximum but in opposite direction. Okay, now where is EY minimum in this diagram? The intensity is minimum at 0 point here. It will be 0 at, the intensity will be 0 at 0, lambda g by 2 and lambda g, right? So here I have lambda g by 2 to be minimum. So now I can put Hz is maximum at this point, at lambda g by 2 point. Here Hz is maximum. Same way Hz is maximum in this direction also. Okay, at both the ends it has to be maximum because the intensity is minimum at lambda g by 2. Now if you see that, as we know, magnetic field is going to form a loop. The maximum intensity is being at wherever the intensity of EY is maximum and EY is minimum. So here Hx max is happening when EY is maximum. Hz max and Hz max is happening whenever the EY is minimum. So this is going to form a loop. Okay, so this is forming a loop, and for every point the magnetic field intensity will be reducing, and the loops will be continuous. Okay, so for, if I am considering this as one loop, the next loop will be for the next field intensity, electric field intensity, again for the next field, again for the next field. So the loop will be in the same direction. So will it be on the top alone? No, the magnetic field will be for the entire Y of the microwave guide. So it will be for the entire thickness of this microwave guide. The magnetic field will be present completely. So when you look, it will be looking like the electric field will be like this, and surrounding it the magnetic field will be like this. Okay, so this will be looking like a rod, and this will be looking like some blanket which is covering it. Okay, so the magnetic field will be around the electric field lines. So I think you have understood this. We will see the top view and the side view so that you will still understand it. Okay. So if I take the top view, top view is I will be able to see the X and Z. I will not be able to see Y. So this is going to be X and this is going to be Z. Okay. Let it be open so that will not get confused. So if I am taking 0, lambda g by 4, lambda g by 2, 3 lambda g by 4 and lambda g. This is in Z direction. So as I said, electric field is going to be there and the magnetic field is going to cover this entire electric field's intensity. Okay. So on the top view, if I am seeing, I can view at lambda g by 4, I can view the maximum intensity reducing towards the ends and becoming 0. This is in positive direction. And at lambda g by 2, I do not have intensity at all because it has reduced in the forward direction also. So when it reaches 3 lambda g by 4, once again the intensity is increasing and reaching the maximum in opposite direction. So it should be in cross marks. Same way in the sideways also. And a magnetic field will be like a loop now because Hx is maximum here and Hx is maximum here. Okay. And Hz is maximum here at 0 point and Hz is maximum here. So this will be like a loop. So the field will be for every electric field points. Only thing is, compared to this loop, the intensity will be reducing for the other loops. So I think you have understood. This is one loop. This is the next loop. This is the next loop. As wise the loops will be getting, the intensity will be getting reduced. So this is the top view. So if you see the side view, if I am seeing the side view, what can I see? I can see Y and I can see Z. So Y will be there and Z will be there. So same 0, starting from 0, lambda g by 4, lambda g by 2, 3 lambda g by 4 and lambda g. Okay. So now if you're seeing, the electric field lines will be seen. So at the edges I can't see. This middle electric field is there in the center of the waveguide, right? So that electric field will be seen from the side view like this. So at lambda g by 4, it is going to be maximum because from 0 the intensity will be slowly increasing, and at this point at lambda g by 4 it will be maximum. See, you can see here it is maximum, right? So that is in the side view. So this point is seen from the side, and as it is reaching lambda g by 2, the intensity is reducing to 0. And when it is reaching from lambda g by 2 to 3 lambda g by 4, the intensity is once again increasing, but what is happening in the opposite direction? It is increasing. So the arrow mark should be downwards. So here the intensity is maximum. Okay. So the magnetic field from lambda g by 4 to 3 lambda g by 4, what is the magnetic field which I am obtaining is, the magnetic field is coming towards me. So you can see here the magnetic field Hx max from the side, if I am viewing, it is coming towards me, it is traveling, and again it is moving away from me. It is coming towards me, traveling, and it is going away from me. Okay. Same way it is happening for the entire Y. And the intensity is going to be the same for magnetic field, because for the first loop the intensity will be the same. For the second loop the intensity will become lesser. Okay, so the magnetic field can be seen like this. I don't want to disturb the lines. Okay, you can see it is coming towards me and going away from me, and it is traveling like this also. So here if you see, this is the magnetic field H, and this blue dots are the electric field E. In the side view if you see, the arrow marks are the electric field E, and the black dots, these are the magnetic field H. I hope you understood this. This is the field pattern for TE10 mode. We saw the expression for Hx, Hz and Ey. So whenever Ey is maximum, Hx is maximum. Whenever Ey is minimum, Hz is maximum. So with that we have drawn the field pattern. Okay, so same way with the wave equations, if I am substituting for TE20, if the mode subscripts are changing, the expressions will change a little. Now what will happen is, along the A dimension, if at all I have TE20, along the A dimension I will have two half wavelengths. Okay, so we will see that in the next class.